Hello everyone, this is Paul Eagleson here, and what I'm going to look at today is how I worked out the solution to problem 4 from week 5 engineering science. So the problem we were given was a train of mass 1500 kilograms decreases its kinetic energy by 23,000 joules. If initially it had a speed of 8 meters per second, find its final speed. So the first thing that I think we need to do is we need to write down a few details. First, we have a mass of 1500 kilograms and we have an initial speed of 8 meters per second. Now, the first thing we need to do is find out the initial kinetic energy. So we know initial kinetic energy can be worked out using the formula half times mass times velocity squared. So insert our values, 0.5 times a mass of 1500 kilograms times by the velocity of 8 meters per second. When we use the calculator, we find that this equals 48,000 joules. So let's get ourselves a little bit of room here. Okay. So the second bit we need to do is we're trying to find the velocity, but first we need to work out what the new kinetic energy is. So new kinetic energy equals the initial kinetic energy, which is 48,000 joules, minus the 23,000 joules, 23,000 joules from the question, and that gives us an answer of 25,000 joules. So now that we know what our new kinetic energy is, we can use the formula again for kinetic energy to find the velocity. So if we write down new kinetic energy, which we know now is 25,000 joules, equals a half times the mass times the velocity squared, and we can rearrange that equation by dividing both sides by half times the mass. This side therefore gets cancelled out, and we now find new kinetic energy divided by a half times the mass equals velocity squared. Again, let me get a little bit of room here. Okay, so we can now rearrange the equation just to find V. So V equals the square root of the new kinetic energy divided by half times the mass. insert our values. V equals square root of 25,000 divided by 750, which means that V can be found to be 5.77 meters per second. And that is how I find the solution to question 4. Thank you.